All right, so let's talk about JPA data modeling. Yesterday we explored the modeling a user, right, and mapping a Java data model to a JPA data model that was persisted into a relational database. And we'll explore a couple other things. This UML class diagram tries to capture several of the challenges of mapping the Java world to a relational world. Right? The Java world is a hierarchical world, right? It's a reusable world. It's it's a transient world, right? Usually, when we think about instances in memory, usually they are very short-lived instances, right? We instantiate an object, and soon it's gone, right? Usually, these objects are short-lived, and whereas in a relational database, usually records are very long-lived, right? These records could be there forever, for quite a while, yes, for years on end, yes. Also, any piece of information that an application might have in its CPU, in its memory, by design, right? We always going to have a very small subset of the actual data set, correct? Right? We might be, whenever we have a query in Google, Google might say, yeah, there's 3 billion pages that match your query, right? But it only shows you 10 at a time. Yes? There's no way that we could ever possibly try to represent that many records all at once, right? So by definition, you're always going to be consuming only a very small subset of the actual content or data that is being stored. Make sense? So the same thing, right? The database might have terabytes of records, but the CPU, the machine, will only ever show you a very small subset of that data. Make sense? Right. So how do you map these two worlds? How do you make it look as if you have access to everything, but only through a short through a subset. Also, the data world is very flat. Okay, these tables are very flat, right? The only way that you can create hierarchies is for records to refer to each other, right? Whereas in Java, it's very common that an object can contain another object, and that object can contain yet another object. It could be indefinite, where you can have these hierarchies of objects containing other objects, implementing the has-a relationship, right? In relational databases, you sort of can do that using primary keys and foreign keys, and we'll see how to do that in a minute. Also, a couple of ideas that are very common in object orientation just don't have any equivalence in relational databases, right? For instance, users and faculty and students that inherit from a base class, right? Those things just have no analogy in relational databases. Make sense, right? So these ORMs that we are exploring today, object relational mapping ORMs. They have to run through some hoops on how is it that they're going to map these two very disparate worlds. Right? How are they going to map one to the other? And JPA is just one of these solutions. So yesterday we did a very simple user. We'll explore today a couple other things, such as these one-to-many relationships, and also these many-to-many, right, of having many students enrolled in many sections and vice versa, right? Where enrollments might say which students are enrolled in which section and what sections are for which student. So we'll tackle each one of these at a time. So yesterday we looked at users. We used entities and generated automatic generation of primary keys. We looked at the tables. We also looked at some custom queries, right? Being able to we saw that the repositories implement for us some out-of-the-box operations, such as deletes and updates and inserts and whatnot, right? And we saw, well, what if we want to implement something of our own, right? Try to find things using a particular criteria, right? Find me all the employees that have a particular salary or that were employed between these two dates. Obviously you want to implement your own queries, yes? And so we saw how to do that, of implementing interface, mapping parameters, using the query decorator to map it to an actual query. We also described that we could use either native queries where we can use an actual SQL query down here. Yes, and we talked about not that being that wouldn't be very desirable since that particular query might be specific to your particular vendor. Yes, and you would tie your code, you would make it dependent on that particular vendor, right? So if tomorrow you wanted to change from MySQL to Oracle or vice versa, then your queries would suffer, right? Because they might be using something that's some dialect that's specific to the vendor. So we instead gave you an alternative where you can use this higher level query, right? That's not SQL. It's called JPQL. So it's a query language that is more object oriented, right? Instead of using actual table names, right? We use classes, right? And whatever that class, whatever table it maps to, well, that's an indirection, right? Where that is resolved later, right? What table does that map to, right? That allows you to navigate the fields in those classes. So it's definitely a better way to go. Well, but we show you both. Sometimes you do need to use something native, right? That it's something very specific to that vendor. We use credentials. All right. So we also expose some of this data using some APIs, right? We implemented some RESTful APIs that allowed us to retrieve an individual user, that allowed us to retrieve all users, right? We also showed you how to use AutoWire to ask for an instance of the repository. Update. Did we do an update? I think we did an update. Yeah. Yeah, we did all the CRUD operations. We did create, we did read, update, delete. We did all of them. Yes. So we got quite a bit far here. Okay. So the other couple of things here that we would like to explore here is what about something more challenging, such as relationships between two classes. Yes. And so here's our first challenge. Right? If you want to model in Java this class diagram, to implement this faculty and section, notice that we have a has a relationship here, right? Where faculty is somehow related with sections, right? Faculty teaches all these sections, right? Or here the faculty authors all these courses. Yes? Normally in a Java language, the way you would model that is that you would have faculty contain maybe a list or a collection of courses or sections. Yes? It would have some variable that is a collection of sections, and maybe you have another collection of courses inside of faculty. Yes? Right? And that's where the first block or the first challenge comes in. Well, how do you represent this in relational databases? In relational databases, the way you represent these relationships is it's backwards, right? The way the relationship works is that you would have a table called faculty, you would have a table called course, right? And the records in the faculty and the records in the course somehow need to be related to one another. Somehow you need to say, hey, these 3 courses over here are authored by that faculty, and these 2 over there are authored by some other faculty. Right. So how do you represent this faculty versus some other faculty, right? So typically in a relational database, the way you represent that is that the faculty would have some primary key, right? So this is faculty 1, 2, 3, and this is faculty 2, 3, 4, right? And then you would have each course say, hey, he's my author, right? Or say, no, that one is my author. There has to be some indirection that says there would be some foreign key. There would be one field here that would point back to the faculty who is the parent. Yes? Right? So it is the children who have references to the parent in a relational database. Correct? Whereas in the Java world, it would be the parent who has a reference to its children. See that? Right, so that's the first challenge between that is so different between these two worlds. Right? And the ORM in our case, JPA, needs to know about these things, right? That how is it that you resolve these two differences? Make sense? All right. So today we'll take a look at how to do that. another challenge is that we have user up there. See that? We have user, and faculty and user are in a is a relationship, right? Meaning faculty is inheriting things from a user, correct? Right. So again, in a relational database, there's no such understanding of what inheritance is, correct? So how would you resolve that? So let's see what JPA would do. Let's see what JPA would do. Let's go and create a faculty object. Let's see. Is this where we are? Yep. Okay, we had Java here, and we had in the models we had a user with all the first name, username, and whatnot. Right. So what if we create here a faculty? Right, and faculty is going to inherit from user. Okay, and I want this to persist. If I have an instance of a faculty, I want this to persist. Correct? Right. And usually when you implement an inheritance is because you are adding some new feature, right, that distinguishes faculty from a generic user. Make sense? Right. So for instance, we might declare here something like a whether I am a tenure, right, and maybe I have an office. Okay, which perhaps not all users have an office, but as a faculty, I get an office, right? And then we would create all the rest of everything. You would have the setters and getters for all these. What else do we need? I think that's all we need. Since we are extending the user already has a primary key, which I am going to inherit. Right, so I don't have to recreate it here. I'm going to say I also want it to be stored in the database in a table. Right, so I'm going to annotate this as an entity, meaning I also want to be stored in a database. Yes, and the default name of that table would be faculty, or would it? Let's see if we do a if we go back to where we were. Let's see, not here, not there, and let's go up again, and let's go down to summer 1, and let's go into webdev su1 server. We just created faculty, right? And we're going to I'm going to in my application properties, so I don't run into any issues. I'm going to change this update to a create, meaning it's going to blow away my data. It's going to recreate my schema, my database. All right, and the reason is that notice that I've created now a faculty that extends user. See that? That means that my tables are going to be slightly different from what we have so far. Let's see what we have so far in the database. Well, if you notice from yesterday, the table that we had is that we have the user object, the user table, which has the following columns. We have ID, first name, last name, password, and username, which match my declaration of what the user is. Right? We have ID, username, password, and first name and last name. Yes? Okay. Now we're adding faculty. So presumably what we would expect is a table also called faculty, right? That presumably would have maybe what? Tenured and office? And what would you expect the username and first name and last name to be? Where would it be? Probably what we would expect is a table called faculty with all the fields inherited from faculty. Yes? From user. So let's try that again. So let's run this. Maven clean install. All right, so let's see what it created. Notice that that what it created here is not exactly what we would expect. Okay, notice what it's doing. It says I'm creating a user object, a user table that has the ID, first name, last name, password, username, office, tenured. See that? So instead of having created a faculty table, what it seems to have done is that it's user who has inherited from faculty, right? It seems that it has merged these two classes together, right, and decided to, instead of creating two different tables, it's going to create one table instead. You see that? Also notice that it created this D type in there. See that? Right? And you can guess what that is, right? That's so that notice it's a string. It's a varchar. Right? It's so that it can distinguish what is this? What in this record? What is it? Is it a user record or is it a faculty record? So that it can distinguish what type. How should it interpret each one of these records? As a user, as a regular user, or as a faculty? If this is a user, then all the fields make sense except office and tenure. Correct? If this were a faculty, all the fields make sense. Correct? Okay, so this is the default behavior that JPA does to implement inheritance. Right? There are two other ways that it can do it. We'll look at it a little later. But this is the default. If you don't say anything, this is what it does. Right? And usually this is the best option. Right? This is referred to as the denormalized implementation. Right? The denormalized means that typically, in a database, you want to break out and have each table store only the data that you care about a particular concept. So faculty is a concept; it would have all the data about the faculty, and then user is a different concept, right? And it would have the data about only that one user, right? But JPA by default chooses this implementation. Okay. The problem with this, what some folks might look at this and says, well, I don't really like this implementation. One of the reasons is that what if I don't have any what if I have tons and tons of users and only a few faculty, right? So this implementation, what you would have is lots of records, way too many records where tenure and office would be null, correct? You have lots and lots of null in your code in your database. Right, and database folks would look at that and says, "Oh, that's horrible. Why do you have all these nulls there?" Right? Your data models doesn't seem to be very useful. It's wasting all this space. Yes, okay, and that's true. It is a wasting of this of space, but it's wasting space with the intent of saving time. Right? What a DBA or a data analyst, their preferred implementation would be to have this, is to have a user table and to have a faculty table where the user table has most of the fields, the username, the password, the first name, and the last name, and the faculty, the other two fields, right, which is the office and whether I'm tenured, right? And so a faculty would be a combination of two records, right? Fields in this table and fields in that other table, right? That's a whole faculty, right? And to fetch to reconstruct a faculty instance in memory, I would have to read from two tables, right? And then instantiate an object, and then some of the fields I would load from this user, and some of the fields I would load from this other table. That's very expensive, right? Time consuming. I would have to hit two tables to fetch the data. Yes, right? In SQL jargon is called joining the table. We would have to do a join of the tables, right? I would have to fetch that record, right? Knowing that these two records are somehow related to one another, create a new piece of data, and then populate the data. Okay, that's very expensive. Joins are very expensive in SQL. Okay, so the wisdom of the JPA designers, engineers, decided that we're not going to go that way unless you tell me to. Right? And unless you specifically tell me to do that, I'm not going to do that. Okay. Instead, I'm going to go and I'm going to merge these into one. Right. I'm going to take these two. I'm going to put it in the user table. So I'm going to skip the join. Yes. And you're going to have a lot of empty spaces, a lot of nulls. Okay. And that's okay because you're saving on time. You're saving on time. Now, if it's two tables, it's not that bad. It's not that bad. To search for a record in a table, right? It's order n. To find a record in a table, yes. To find a record on a table that is somehow related to another record on the table, right? That's n squared. Okay. What if your inheritance tree? What if your inheritance tree is much more sophisticated? You have users, you have faculty, you have tenured faculty, non-tenured faculty. You have a whole bunch of inheritance trees. Very, very deep inheritance tree. Right? For every inheritance that you do, you would have an additional table. Correct? Right? And you would have to add a new join. Right? So if you have 3, 4, 5, 6 tables, you would have to join 2, 3, 4, 5 tables. Right? That means that it becomes n squared, n cubed, and it becomes very, very expensive, time-consuming, searching for all these tables. Correct? So the good engineers at JPA decided to no, that's too expensive. We're going to go this way. Everybody okay? Right? There's a whole lecture on the two other options. We're not going to use them. Well, maybe I'll touch on them. But in this course, we're not going to use them. In the database course, we do use them a lot. Not here. Faculty. All right, so let's build a couple of these here. Student also example here also uses inheritance as well, right? Uses JPA and graduating years, right? So if we create a student here, right? If we create a student, and students have GPA, so oops. We have a private, what is it, float? So this is a float, GPA, and what else do we have? Graduating year. So we have private integer graduating year, and we declare this as an entity. And we generate the setters and getters. What? There we go, entity, and right. If we regenerate this, oops. If we regenerate that. You'll notice that the new SQL that is used for generating the new user will be, again, it will be a something that breaks. What? Demo, blah 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 blah. Income, time lapse. Did I misspell something? Entity. Oh, entity, and this is extends. What is it? Extends user. Yeah, it was asking for a primary key. It didn't have a primary key, so let's do that again. All right, there it is. So notice that it put together tenured and office. That's from the faculty. And notice that I put the GPA and the graduating year also in the user table. Yes? So it's using what it's called the denormalized strategy. The denormalized strategy. There's two other strategies. It's the normalized strategy and the one table per class strategy. Right? We'll take a look at those, but we're not going to be using them in this class. All right, excellent. So let's move on. Let's take a look at one-to-many.